I did something that no student has ever done in the history of my life before. I took an exam for a class I wasn't enrolled in on March 16, 2022 at 8:30 a.m. So here's the backstory. As I explained in my last video, I didn't do so well in Calculus 3. 70% of the reason for it was because of my laziness and my addiction to gaming. Because as you know, Calculus 3 is labeled as multivariable calculus. So I was thinking, oh, I have a good foundation for Calc 1 and 2. And like Calc 3 is just an application with multiple variables. So I thought, oh, I should be fine. I should breeze through this. But I was never so wrong. But then on this in January of this year, I decided to relearn the entire course myself, and I met the professor basically. So this professor, I had him for Calculus 2. I got an 83.5% in his class and subsequently an A grade. And I realized he was teaching Calculus 3. So and he was really happy to see me. So I asked, hey, do you think I could, take your midterm exam? And then he's like, yeah, as long as you're here that day. And so I ended up taking his midterm exam. I ended up getting an 80% on the exam, which is actually an A. And the average was 55%. So my professor, this particular professor, he does not do a bell curve. And he has a grading scale that goes something like this. 90 to 100 is considered A plus, 80 to 90 is an A, 70 to 80 is an A minus, 64 to 70 is a B plus, 58 to 64 is a B, 52 to 58 is a B minus. You keep going down the list, and anything below 30 counts as an F. You think it's lenient at first, and it's actually pretty generous. And because if you get less than 30% in a course, you kind of deserve to fail. But the thing is, it's because it's so often, it almost always naturally falls into a grade distribution like this. And he said that he doesn't want, to have to punish students just because of the bell curve, because there was one, because usually with this grading scale, only one or two people, usually it's only one or two people who get A pluses. But there was the rare exception one semester, he told me, where 3 students got above 90. And he's like, I should give all of them A pluses, because why should the third one be punished because of a bell curve, right? So yeah. Here is the midterm exam. I shall also mention that this is this was the second midterm. I didn't really know that he was teaching this course, so I missed the first midterm. But basically, what happened was I just realized it in the middle of the semester, so I didn't get to see the first midterm. But the second midterm, in all of my years, the second midterm has always been, I've never done well on any second midterm. Because usually it's the first midterm is the easiest. It's not easy, it's the easiest of the 3 assessments, the 3 big assessments. The second midterm is the hardest, and the final is somewhere in between. So I took the second midterm, but I already had enough preparation. So let's dive into it. I'm gonna tell you the correct answers, where I got right and where I got wrong. So question 1. The question 1A was prove the following limit exists. Here was the limit. It was lim. Oh shoot, I forgot my pen and drawing pad. I will be right back. Hey guys, I'm back. I'm sorry about that, but writing with the mouse it will just be a real pain in the ass. So I'm gonna do it like this. Okay, so the limit was, so lim as x and y both go to 0 of x cubed plus y cubed over x squared plus y squared is equal to 0. Prove that this limit exists. How do you do that? That's actually a very good question. I got this one wrong. I got 2 out of 3 on this question. It was worth 3 points. The exam was out of 30. Because like I understood how to use the squeeze theorem. The technique for this is the squeeze theorem, but I didn't use the right formulas. So the first thing you do, the right way to solve it first is you consider the absolute value. That's x cubed plus y cubed over x squared plus y squared. Well, you and I can both agree that this is equal to just x cubed plus y cubed over x squared plus y squared, right? Because x squared plus y squared will always be non-negative for any real values of x and y. What you do here, this is a little tricky, but what you do is use the triangle inequality. And the triangle inequality, I'm going to make a note on the side, is when the absolute value of a plus b is less than or equal to absolute value of a plus absolute value of b, like this. So this is less than or equal to x cubed over x squared plus y squared plus y cubed, absolute value of y cubed over x squared plus y squared. If you aren't unconvinced by this, go look at videos on proofs of the triangle inequality. I'm not a channel that particularly does proofs unless I really want to. So this, and now I'm going to make a bit of a note on the side here. So when you have this, x cubed over x squared plus y squared, this is actually going to be less than or equal to, hang on, something is coming off as very funny. Wait, hang on. I was gonna say that this was less than or equal to, oh, sorry, I was thinking of something else. So no, this is right, this is right. So this is x cubed over x squared. Do you see why? Because I remove y squared, and it's like by removing y squared, you know, y squared is a non-negative number. When you decrease the denominator of a positive value, then the whole value overall decreases. So it's like I made the value of the denominator in this equation smaller. So now the value has increased, or at the very least stayed the same. And this is equal to absolute value x. A similar argument could be made for this term here. Absolute value of y cubed over x squared plus y squared is less than or equal to y cubed over y squared, because you can just remove the x squared term and the overall value will increase, or at the very least stay the same. And this is equal to the absolute value of y. So we can say that this is less than or equal to absolute value of x plus y, absolute value of y. Okay, so I am going to erase a portion of this. Hope you guys understood that. If you don't, let me know in the comments section or email to me. I'm gonna be giving some practice problems at the end of the video, so stay tuned for that. Okay, so we know that this is true, right? I'm gonna write this very carefully. Okay, so this x cubed plus y cubed over x squared plus y squared, that is less than or equal to x, absolute value x plus absolute value y. We deduced that earlier. But this, when you have absolute values on this entire form, this is always going to be non-negative. So this is also true that this is going to be greater than or equal to 0. So this statement is also true. Now, I am going to add the condition that the limit of x, y goes to 0, 0 on the entire inequality. So then I'm going to do something like this. Lim x, y goes to 0, 0 on the entire inequality. So here, the lim x, y, 0, 0 on 0 just gives you 0. So 0 is less than or equal to lim x, y goes to 0, 0 on x cubed over y, x cubed plus y cubed over x squared plus y squared. And this is less than or equal to, well, 0 plus absolute value of 0 is 0. So this is the squeeze theorem. It's like this limit is greater than or equal to 0 and it's less than or equal to 0. So by the squeeze theorem, the limit zero zero of this absolute x cubed plus y cubed over x squared plus y squared is equal to 0. And that also implies that the limit of x and y going to 0, you can just remove the absolute value bars. So x cubed plus y cubed over x squared plus y squared is equal to 0. And you are done this part of the question. I'm going to give you a bit of a note. I've seen this on a few YouTube videos, and I saw this when I was desperate the first time I took the class. Don't use polar coordinates, or at the very least, I highly discourage it. Do not. I made the mistake when I first did this question, it was another question, but proving a limit exists I used the polar coordinates, and I got 0 because the TA didn't understand my method. A side note for you guys, when you are doing a problem in class, you must use the content that your professor taught you. For example, if you use L'Hopital's rule to find a limit on a test, but you haven't learned L'Hopital's rule by the professor, and you don't use the method you're asked to do, you're not going to get the credits. So yeah, you can use polar coordinates, but I highly discourage that. Use the squeeze theorem. And oftentimes when they tell you to prove a following limit exists, most often it's 0. It's not the only value, but it's this is the types of question I've been given on practice homework and midterm exams. So yeah, that's part A. I'm going to erase the whole thing. So 1B was also worth 3 points. Prove the following limit doesn't exist. And the limit was this. it was lim as x and y both to go to 0. And x squared, y squared over x squared plus y squared. Okay, so how do we prove this limit doesn't exist? That's a very good question. You basically, all you have to do is find two curves going to 0, 0 that have different values. So one of the curves you can use is at line x equals 0. So at line, basically say, not line, at line x equals 0, right? And basically that would be, so x is 0, so just worry about y. So say the limit of y goes to 0, and then it's y squared over, did I do this question? Something's coming off a little strange to me. Sorry, something's coming across a little off. X is 0. So y goes to 0. Y squared over. Okay. I think I made a slight miscalculation error. So x is 0, y squared, and that's equal to 1. For some reason, I had it equal to 0 on my side, but that's okay, I guess. It's equal to 1. It's equal to 1. I'm sorry about that brief moment of confusion. Line, okay, so, but try a different line. If you try, okay, so try a line x equals y. You can also try y equals 0, but yeah. Okay, so when you have x equals to y, just say limit y goes to 0 again, but this time x is equal to y. So that would be y squared over y squared plus y squared. That's 2y squared, and that's 1/2. These are not equal, so limit does not exist. All right, so that is the first question done. I got full marks on that question. Question number 2. This one I did the poorest on. I only got 1 out of 6. So yeah. So it's like, I'm gonna type this out actually. Text. The question was, let f be a differentiable function. Then check if the functions, first one is v is equal to f of the square root of x squared plus y squared. And b was z is y times f of x over y squared. So check if these satisfy the partial differential equation. I'm going to say the words PDE. Check if they satisfy this equation. Y dz dx minus x dz dy is equal to 0. And why did I do so poorly? Well, here's what happened. I tried to do it directly. So here's the wrong way to do it. I said dz dx is equal to fx of x squared plus root x squared plus y squared. And then I said that multiplied by 1/2 x squared plus y squared. I just did the chain rule like this. -1/2 times -2x, which is basically negative x fx x squared plus y squared over this. And then when I did it like this, dz dy, it's I said that was f of x over y squared plus y f of y, f sub y. So this is the wrong way to do it, guys. I'm just letting you know, and I hope you can see the problem before I'm done writing everything out. 2x over y cubed. And then I was like, this doesn't make any sense. You get like f of x over y squared plus it was just so hard. I tried directly mixing it and I'm like, how is f x equal to fy? And I just completely got confused. Don't directly do it. Use the chain rule properly. Here is the correct way of doing it. Okay, so here's the way of doing it correctly. I have my other sheet right here. And I can guarantee this is correct. I don't I didn't make any mistakes. So first of all, z is equal to f of, I'm gonna make this look a little nicer, x squared plus y squared, right? Do a substitution. Say w is equal to root x squared plus y squared. Okay. And now we have to satisfy this equation PDE, y dz dx minus x dz dy is equal to 0. All right. Well, and okay, so this is what you do. You basically apply the chain rule. Here's what, let's find dz dx and dz dy individually first. Say that dz dx is equal to df dw times dw dx, because this is z is f of w and f of w of x. So it's like z is f of w of x, right? So then to find the derivative of partial derivative of z with respect to x, this is what you do. Okay, and this is much easier. So f, that's equal to fw times 1/2 of x squared plus y squared to the power of -1/2 times 2x, -2x, yeah, sorry, which is negative fw x over root x squared plus y squared. Dz dy is equal to, same thing, similar concept with the chain rule I did up here. So that's df dw
dw dy. And that is equal to f sub w, that's df dw, yeah. And then times 1/2 x squared plus y squared negative 1/2 times negative 2y, which is equal to negative fw y over x squared root x squared plus y squared. Okay, now let's just plug this into the equation. This gives you, so y dz dx minus x dz dy, that is y times negative fw x over root x squared plus y squared minus x dz dy. Minus and minus becomes plus, so that's plus fw xy over x squared plus y squared. And negative xy fw plus fw xy, that's equal to 0. So yes, this first formula satisfies the partial differential equation. Part B. The second one was z is equal to y times f of x over y squared. Okay, well, this time we apply this similar concept. Let w is equal to x over y squared, so we can apply the chain rule. dz dx is equal to, let's use the product rule. So if we're integrating with respect to x, we can treat y as a constant. So y times df dw dw. You normally wouldn't have this much time to write this much on a test, but I'm just trying to explain everything in depth as much as possible. So yeah, in a test, just write what you know and get to the answer as fast as possible. Y f sub w, and then differentiating with this stuff. So dw dx is just 1 over y squared because you treat y like a constant. 1 over y squared, which is fw over y. Okay, dz dy in this case. First, apply the product rule between y and f of x over y squared. So derive with respect to this. So the derivative of y is just 1. So that's f of x over y squared plus y, and now apply the chain rule, your y times df dw plus times dw dy. Okay, now this is equal to f of w, f of w plus y, fw times negative 2x over y cubed. And that is equal to f of w minus 2fw x over y squared. You can plug this into the PDE and like see for yourself that this does not satisfy the partial differential equation because of this oddball f of w here that doesn't get canceled out by anything. As a quick note on a strategy on a test, like if the answer is clearly evident, right, it is clearly evident that this does not satisfy the partial differential equation. I've BS'd it a few times and I've actually got more marks than I deserved. It's like, I don't know how to show the rest of the calculation. Well, from my missing puzzle piece, it is clearly evident that this is blah, 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 blah. The Earth is also flat, by the way. I know, I'm crazy. All right, so that is question 2. So yeah, this, in case it hasn't become obvious, does not satisfy this PDE, and you can plug it in yourself and see. So clear all my drawings. This is question 3 now. Question 3 was slightly easier. It was much easier than number 2. So questions 3, 4, and 5 I got full marks on. Basically, suppose you are climbing a hill. Shape is given by z is equal to 1,000 minus 0.01 x squared minus 0.02 y squared. Okay. X, y, and z are measured in meters. I don't think that really matters. I didn't make the question. Okay. Now so basically, question A was, if you walk due south, will you start to ascend or descend? At what rate? Question B was, in what direction is the slope largest? What is the rate of ascent in that direction? All right. So basically, this question is a fairly routine thing. It involves the directional derivative. And the way the directional derivative is you have a unit vector, you have coordinates, and the general formula for the directional derivative at a point xy is du f of xy is equal to f of x at times a plus f of y x y times b, where a and b come from a unit vector. This is the general formula. I'm going to write and say where we will be using this. Okay, so part A, if you walk due south, think about it. Walking due south means you are walking directly in the down direction. So your u, walk due south, means u is 0, -1. It could, this y coordinate could be anything, but it has to satisfy a unit vector, and the magnitude of this u is 1. So it's 0, -1. That means walk due south. Okay, I'm going to repeat it until I die. So we just apply this directional derivative formula in at this point. Du of f of 5080, because wait, did I not? Oh, I forgot to, oh shit, I forgot to mention that you were at a point. You were at a point with coordinate, I forgot to mention something, 50, 80, 847. This was your point. I'm so sorry, I completely forgot about that. Okay, so du f of 5080 is equal to fx of 5080 times a, which is 0, and b is -1, times 0, plus fy, 50, 80 times -1. Well, the du is equal to negative, and fy is so it's -1 times, so the partial derivative of f of xy, which is the respect to y, is -0.04y. So -0.04 times 80, which is 3.2. So the answer is you will descend at a rate of 3.2 meters per second walking due south. Okay, part B, this is just something you have to know. If you can prove it by heart, then good, but I've done so many questions that I don't require the proof. The direction where the slope is largest, it's like the largest, the rate of descent where it's like the largest is at the gradient. If you don't want to prove it, then just take it to heart, but it's at the gradient vector. This is where the direction of change is the largest. So f, that's equal to fx, fy. And that is equal to, so remember our function here, that fx is -0.02x, fy is -0.04y. And that is equal to, so -0.02 times 50 is -1, and -0.04 times 80 is -3.2. So this is where the largest rate of change or ascent occurs. And the rate is the magnitude of the gradient, which is when you do it yourself, 1 squared plus 3.2 squared is 11.24 meters per second. Okay, so that is question 3. Question 4 was also fairly easy. If you are going to study one thing on a midterm, I highly recommend you study this thing because it's easy and it's almost guaranteed to be tested on. Consider the function f. So this is question 4. Consider the function f of xy equals 6xy squared minus 2x cubed minus 3y4. And basically find and classify all the critical points. I've done these types of questions so often, it's as easy as making breakfast in the morning. First of all, set fx and fy equal to 0. So let's find those partial derivatives. Fx is 6y squared minus 6x squared. And that's equal to 0. And fy is equal to 12xy minus 12y cubed, which is 0. All right, so here you have 2 unknowns and 2 equations. You should be able to find the x and y, these critical points. Okay, so from here, x squared is equal to y squared. And from here, xy is equal to y cubed. So if xy is equal to y cubed, there are 2 possibilities. Either y is equal to 0. Do not make the mistake of just directly dividing by y. It's possible for y to be 0. Or x is y squared. So first say y is 0, then divide both sides by y. X is y squared. So we have to consider both all of the cases. First, let's consider the easy alternative. If y is 0, then if y is 0, then x is equal to 0, right? Since x is y squared. And then f of 0, 0 equals 0. I don't think you need to say equals 0, is a critical point, CP for a critical point. Okay, now let's consider if x is equal to y squared. What do you do here? Well, you would just say x squared is equal to y squared. We've done that before here. Plug this in. So it's like x is equal to y squared. So y to the power of 4 is y squared. So y4 minus y squared is equal to 0. Okay, and then y squared times y squared minus 1 is 0. So you have y is 0, y is 1, and y is negative 1. So the critical points, or CP, are f of 0, 0 is 0. We talked about this earlier. F of 1, because, okay, so if y is 1, then, sorry, if y is negative 1, then x is equal to 1. And that's equal to 1. And this is also equal to f of 1, 1, because if y is 1, then x is 1. Okay, now we do the second derivative test to classify them. Okay, so the formula is you use this discriminant, capital D. It's equal to fxx fyy minus f squared xy. And yeah. Okay. Well, I think let's first find fxx, fyy, and fxy then, yeah. So fxx is negative 12x, because fx is 6y squared minus 6x squared. So fxx is negative 12x. Fyy is, I didn't write this down. Fyy is, so fy is 12xy minus 12y cubed. So that's 12 is 12 12x. Am I doing this right? Minus, I don't trust my mental calculations that much. Minus 36 x. Yeah. Minus 36x y squared. Okay, that's right. And fxy, we already found that's just 12y, because, yeah. All right. So basically for f of 0, 0, d is equal to fxx, fyy minus f squared xy, which is equal to negative 12 times 0. It's just plugging it in now. Minus 0 squared is fyy. Yeah, because 0, 0, 0. Minus f squared xy. So, but then y is also 0. So it's just 0. D is 0. This is indeterminate. You can't tell anything. not undefined, but indeterminate, meaning you have to use another way other than the second derivative to attest. For f of 1, -1, d is equal to, so basically fxx times fyy minus f squared xy, which is equal to, basically now just plug in the formulas. X is 1 and y is -1, so 12 times 1 times, wait, hang on. Fyy, yeah, fyy 1 minus, yeah, times -24 for fyy, x is 1 and y is -1, minus 12 times -1 squared. And when you do that, that is, let's see, -12, 288 minus 144, it's equal to 144, which is greater than 0. And fxx at that point is less than 0 because x is equal to 1. So this is a this point f of 1, -1 is a local maximum. Okay, let's try f of 1, 1. You can just plug it into D. I don't want this video to go way too long. It's also going to be 144, which is greater than 0. And the fxx is also less than 0. You can verify this for yourself. So this is also a local maximum. So this point is indeterminate, and these two other critical points are local maximums. Okay, so let's do the last question. Okay, so basically we're given a function f of x, y is equal to 1 over 1 plus x squared plus y squared squared. Okay, and now I'm going to type out the rest of this question. So part A says, let the radius r be greater than 0. And you see the word radius, you should be immediately thinking of polar coordinates. And let dr, so the region D, it have something at like of x and y such that x and y are both greater than 0, greater than or equal to 0. Both greater than or equal to 0. And x squared plus y squared is less than or equal to r. Less than or equal to r. Okay. First, we have to evaluate this. We have to evaluate the function, or no, we have to evaluate the double integral from over this region D, f of x, y, dx, dy. And part B is we need to prove, like, so after we solve part A, we need to prove that this integral is this integral 0 to infinity, 0 to infinity, dx, dy, 1 plus x squared plus y squared squared is equal to pi over 4. Okay. let's do this. Okay, so this question might seem a little daunting at first and a little strange because you're not dealing with an exact visible circle, but like just use what you know in polar coordinates and you can get it through. The first thing I'm gonna do is I'm gonna draw a diagram. So X and Y are both non-negative values, as you saw already. And you have this, and you're integrating over a quarter circle, R. Let's call it R, okay? And this is your D area, okay? Keep that in mind. Also, f of xy dx dy. Well, dx dy is equal to dA, but when you're evaluating in polar coordinates, dA becomes r d theta. Again, I'm not someone who does proofs. If you want the proof of polar coordinates, go watch a proof on polar coordinates. Not that I'm not happy to teach it, but I think there's better things we could be utilizing our time on. Okay, so we have this, right? So now we can just go evaluate this. So basically, let's say dr f of xy dx dy. I'm going to mention part A before I forget. Dx dy is equal to, we can just write out this. So the r goes from 0 to capital R, where R is a constant whose radius is currently unknown. R d theta. Remember, we're using this function, we're turning into polar coordinates, over 1 x squared plus y squared is r squared in polar coordinates, r squared squared. Okay. And when you, I'm not going to teach the substitution method because I'm not here for that. Oh, and I almost forgot to mention, you're integrating this from 0 to pi over 2, a quarter circle. Okay. So that is from, after you do the substitution method, you go from 0 to pi over 2. This is 1 over 2 times -1 over 1 plus r squared d theta, which is yeah, you just multiply by 2 theta. So that is negative pi over 4. Hang on, something seems a little, wait. No, I did this part right, okay. So -1 over 1 plus r squared. Oh, yeah, I forgot to take the point bounds from 0 to r with the antiderivative. R squared from 0 to r d theta. And that, okay, so now pi over 2 times 1 over 2 is pi over 4. You can just directly multiply pi over 2 with the theta because there's no theta variables here in where I'm integrating. So 1 over 2 times pi over 2 is pi over 4. And with respect to r, -1 over 1 plus r squared. And plus 1. Okay, so that's part A. Now part B, x and y go to infinity. Well, that's basically saying that this radius goes to infinity because it's like x and y go to infinity. So then the region where you're integrating goes to infinity, and that means the r goes to infinity, right? So basically all you have to do for part B, this integral is equivalent to saying that lim as r goes to infinity, because it's like an infinite circle as x and y goes to infinity, pi over 4, -1, you're just evaluating the limit now, r squared plus 1. This term cancels out to equal 0, and your 1 times pi over 4 is just pi over 4. Okay, so now you are done the exam. I was gonna like talk about my thoughts and some stuff, but I'm running way over time, and it's actually my bedtime. I shot this video very late. So yeah, I am exhausted too, by the way. I did not expect it to take this long. I finished just in the nick of time, by the way. So whew, thank you very much for watching. I'd love to stay, but for now, I have to jump. I'll see you guys on the other side of the bridge. Catch you next time.